So do we have any creationists in the audience today? Intelligent design advocates? Well, not sarcastically? Not sarcastically? All right, let me just make sure this thing works. Oh, very good. Okay. So, well, perhaps there are some at home, too. Well, I have a challenge for you, if you're out there listening to me. All right? I think it's the most important challenge you have to meet. And it goes a little something like this. Provide examples of how your alternative theory can help us solve problems in the realm of biology. Why this particular challenge? Because I've seen a lot of creationist, evolutionist debates, and there's this habit where they compare piles of evidence. The evolutionists will say, I have piles of evidence that evolution is true. The creationists will say, oh yeah, I have piles of evidence that there must be an intelligent designer. Or my pile of evidence is superior to yours. It meets superior standards. Oh yeah, well my standards are pretty good too. They're backed by this person, this person, this person. Each person comes away thinking that they won the debate. But how do you force your opponent, or at least a good portion of the audience that might be on your opponent's side, to get those gears churning in ways that they might not normally churn in a typical debate? How do you force them to answer questions and defend their view in a way that doesn't typically come up? Because there's one very important thing that typically is missing from the intelligent design side of the debate, and it doesn't really. They try to bring it up, and the evolutionists will try to bring this up in various ways, but it's not perfectly clear what's necessary for the evolutionists to provide. And of course, this has not happened yet. They have a scientist here saying, I have discovered a method to isolate and measure the properties of the designer itself. The evolutionists will often point this out. You're not finding the designer. The intelligent design proponents say, well, that's not something we have to answer. We can infer design, and that's good enough. Well, it's not good enough because it's never going to meet this type of challenge. Now, I'm in the midst of putting together a video blog that I hoped to launch before SkeptiCamp took place. I've been really procrastinating on it quite a bit. But when it is ready, which should be in a week or two or whatever, you'll find it at this address. It's YouTube and MSL Vlog. That's my initials, Vlog. But what's interesting about this particular challenge, I've used it on the internet quite a bit, is the reactions you get from the intelligent design community. Because at first, they don't know how to react, because this question doesn't come to the forefront of a typical debate. Sometimes they will lie, cheat, and steal to come up with answers, and I'll give you some examples of those later. Or they will brush it off as not important. This does not happen too often because your opponent will typically recognize that most of the people in the audience are not going to buy that. If the evolutionist is saying, well, we're helping conserve species, and there's medical research, and there's all this and stuff, your opponent really can't come back to that by saying, well, that's not important. Although sometimes they do. But the other more frequent thing that tends to happen on the internet, in my experience, is that they just stop the debate. They don't, sometimes abruptly, they realize that they just don't want to talk about this anymore. Because you've put them on the defensive in a way that they're not used to. Of course, you're going to have to back up your side of the debate with examples of how evolution can solve problems in the field of biology. And there's a very good website. Unfortunately, the URL is a bit long, but actually, all you really have to remember is this part: evolution.berkeley.edu, or Google Understanding Evolution. Once you're there, there's this resource library, and there's this very nice link, How Does Evolution Impact My Life? It's got many, many examples in fields of medical research, animal conservation, and agriculture for defending evolution as a thing that can solve problems in the field of biology. Most of those examples in medical research will often be countered by creationists by saying, well, that's only microevolution. You see, they'll typically try to divide evolution into two groups. You have microevolution, which is just small-scale interspecies stuff, and macroevolution is somehow different in their mind. From the scientist's point of view, it's not, but in their mind it is, which is one species turning into another. But there's one group of solutions in there in animal conservation where macroevolution applies the best. And I think for the purposes of this particular presentation, I'm actually not going to go into this too much because this is actually one of my favorite animals. This is the kakapo, a very rare parrot-like bird in New Zealand. Okay, so, and this bird was basically saved by understanding evolution, not in micro evolution scale, but in sort of the macro, look at the big picture, species relationships kind of a scale concepts. And the reason why this is important, this is an endangered species. You don't have the luxury, by definition, of breeding lots and lots of these birds and experimenting on them. You have to hone in on a solution a little more urgent, a little more surgically, and understanding how birds, in this particular case, if you look back on this website, it actually has a very nice article about it. In this particular case, the ratio of males to females being born was way off to sustain their population. And they figured out that the certain dietary habits were contributing to this. And you can't, again, you're not just looking at the particular species, you're looking how it relates to other species and how they have a similar, how their sex allocation is divided about that. I can probably go into lots of details about this. I actually cut off a lot of those slides, I think, yes. But when you're on the evolution side of the debate, I just wanted to make this particular point. If you do use this tactic of mine, if you challenge them to solve problems in the field of biology, you have to try to avoid, on your end anyway, this particular fallacy, because you might be accused of this from science of philosophy majors in the audience. It must be true because it is useful. See, this is a logic fallacy. Just because something is useful doesn't mean it's true. Instead, you want to try to always frame your answers in this particular way. It is useful because it seems to be true enough. You see, it seems to be true enough, so let's make use of it. Instead of, actually, I think the words, okay, well, right. Anyway, so actually, I think the words of it should probably be in the, we can make use of it because it seems to be true enough. And that's just something to remind people about. But now for your challenger's side, there are some rules. When I've seen examples coming to me of intelligent design trying to solve some kind of problem or do something, it's usually very thin, doesn't mean much. So I developed some rules for this challenge. If you're going to accept the challenge of coming up with a way for intelligent design to solve a problem of biology, these are some of the things it has to do. Your example has to appeal directly to the designer or the creation of life itself. Inferring a designer is not good enough because you're not really proving an intelligent design. You're just inferring that something is very complex, which could come up from a lot of different ways. Your example must be non-trivial, something that could not have easily come out of any other theory. And sometimes something as non-obvious to the general public is obvious to scientists. So if it's something that's relatively obvious to scientists, I count it as non-trivial because from their point of view, they've already sort of figured out that kind of stuff. So sometimes some research might be, if an example comes to you, sometimes you have to do a little bit of research to see if other scientists in evolution or some other field has already been working on that for years. Because that, I'll come up with some examples of that too. Also, it must not be a restatement of evolutionary theory using creationist terms. Of course, rule number 3 might be considered a restatement of rule number 2, but I state it explicitly because this happens a lot. The best example was the Evo-Devo. Evolutionary development science started bubbling up. The intelligent design community came up with this alternative idea called front-loading, which it basically expresses the same idea, they just put it in creationist terms. So they're not really inventing anything new, they're just taking an idea from evolutionary study and putting their own terminology to it. And of course, it must refer to the real world, not some made-up place. I was actually working on a short story that I'll probably put on the internet someplace of a planet where intelligent design really is a science because they really found evidence of a designer. And they've come up with examples in their real world that would prove that. But fiction is not good enough for the examples to meet this challenge. It has to apply to the real world. And by extension, this also excludes fraudulent claims. Someone could claim something applied to the real world, but when you look deeper, it doesn't. That would be considered just a fraudulent claim, and it would basically be a fictional world. The intention was not fiction, so perhaps in the libraries, it would be labeled under nonfiction, but it would still be fictional as far as the rules are concerned. But at the same time, there is some leeway you can grant your opponent. All right? Their example does not have to work in practice yet. It could be something that works in principle is good enough. Maybe it requires a special machine that hasn't been built yet. If you can describe what that special machine is in a way that could work feasibly in principle, okay, I would let that be a good example. All right, the problem does not even need to solve something that's terribly important. It doesn't have to necessarily be an example of medical research or something like that. If you come up with a really good reason why the blue-footed booby's foot is blue, that might be good enough. Evolution already solved that problem, so it's a bad example. But at least there's a couple of really good solid theories. And also, you do not necessarily need to provide a definitive solution to a problem. You don't have to say, this is the solution to this medical problem. You could say, here's an approach we can use to figure out what the solution would be using intelligent design. We may not have the answer yet, but we can, if we assert a design process right here, it'll give us a clear answer of where to go. And an example that I can give that this almost works. It almost follows the rules. Okay? Well, it's something I like to call rib cage hinges. I actually have a little bit of I'm going to just read off a little bit of a video blog script because I think this will. All right, so this is how the example goes. It is well known that machines designed by humans will often contain doors, hinges, or screws to help open things up so the parts inside can be fixed or replaced easier. Perhaps by that logic, we might conclude that the designer had motivation to place such things into our own rib cages, though we never noticed them before because they atrophied from disuse. But if my intelligent design theory is correct, we should find evidence of those hinges. Perhaps they might even be more pronounced in fetal stages. And this would obviously be a boon to various surgical procedures and first aid procedures, as this could solve problems of how to improve surgery in people. All right, that fits most of the rules, of course, but unfortunately it does not apply to the real world. We would not really expect to find hinges in rib cages, but at least you have something, that kind of idea to work off if you can try to meet my challenge. And these are some real examples I've seen that actually don't work. So a prediction from intelligent design would be that the complexity of living things will always be much higher than originally thought. First of all, this is a trivial statement, and evolutionary biologists actually end up making the same claim. You don't often hear, they don't phrase it that way, but they will. But when they talk about how there's an opportunity to increase complexity in a living thing through many, many iterations. Since we don't know how many iterations there were in these generations, they're always going to be more complex than we thought they would be. Is sort of that's a summary of a lot of what I read from biologists. So they were already thinking in terms of that anyway. And then, now I have a slide specifically about this, so I'll talk about it later, how it differs from my hinge example, because someone did ask about that. We inspire scientists to reverse engineer molecular machines like the bacterial phloem to understand their function like machines. Well, the function, first of all, was not even discovered in the context of the designer, and historically, evolution has actually worked out a lot of details, and intelligent design has provided nothing. But I'll get to more about that a little later. It is a specific example I've seen from some people. Antibacterial soap is not quite causing bacteria to become more resistant to the agents as quickly as some scientists thought. This was kind of an actual thing that some scientists were saying. We shouldn't use antibacterial soap because bacteria could become resistant to it and we have bigger problems. That is actually, that's a general problem that might crop up, but it turns out that antibacterial soap isn't doing this quite as quickly, and some intelligent design proponents are sort of harping on this thing. You see, evolution didn't predict this properly. The problem, though, is that they're not really referring to a designer at all. They're just sort of restating evolution. It's just not as fast some species as possible. And this is another topic I can actually talk about a lot more often, but I'll just mention anything that has to do with junk DNA. It's just a bad nickname is the bottom line. All right, once you get past the word junk DNA and just call it non-coding, what's the technical term? Sequence. Yeah, non-coding sequences, you get past a lot of that stuff. And all of these things were actually answered within the framework of evolution. None of them were directly demonstrated a process of intelligent design. But what about that motors one that keeps coming up? What's the difference between finding a motor in a flagellum and hinges in the rib cage? And my hinges being completely fictitious, a motor seems to really be in the flagellum. And I have to apologize for this slide. I added it to in the last minute. I really couldn't think of a concise way of putting this argument together. But this is basically the summary. Well, actually, maybe I'll just focus on these words first. These should have been up there. It's pretty trivial to find a motor and then say, that thing is complex. Therefore, it must have been designed. It's a whole different beast to say, we expect a certain I didn't put the word strategy in there. Well, it doesn't matter. We expect a certain strategy to have been used by the designer to put these certain specific types of complex things in life forms. Therefore, we should discover them in places we didn't know they exist, such as hinges in a rib cage or screws putting snail shells onto snails. Or anything like that. That maybe there's evidence of these things happening that nobody knows exists yet. All right, that's a completely different beast. If intelligent design was able to come up with examples of that, I'm pretty sure most, and they work out, if we really did find that there was evidence of hinges in rib cages that nobody noticed before, some scientists are still going to be skeptical that there's an intelligent designer out there. But importantly, the intelligent design community at that point would have gotten everybody's attention. You know, you can't escape the fact, if that were to ever happen, that suddenly intelligent design came up with something that solves some problems in the field of biology. What? You know, if that happens, then it happens, and we can't ignore it. That would give them a one-up on everything that they've ever done so far. This really has very little to do with my specific topic, but it's something I do like to remind people about. How many of you know Phil Plate's "Don't Be a Dick" speech? How many of you have heard that? I actually had the same message long before he did. My message was be diplomatic. The idea is whenever you're debating anybody, always, especially if you're going to take my approach and you're not going to hardball them for evidence at every little point, you just want to sort of let them sort of take control of what their own arguments are. Just give them the benefit of doubt for a lot of different things. All right? If they want to call their theory a theory, don't harp on the fact that it's not really a scientific theory. I'm not going to bother going down that route. I have more important things to say. You know, my thing I say is, well, show us what it can do. Show us what it can do. I don't care if it's a theory or not. If intelligent design can do something, it does something. You know, so And so be diplomatic in your approach. If they bring up God into the picture, I just mentioned this. I always say this to some evolutionists whenever whatever your belief is God, whether you're a hardcore atheist or agnostic or whatever, just remind them that evolution does not rule out the existence of God. God might still exist for all we know, but the entity is currently considered superfluous in the pursuit of science. So actually it does connect, because by not coming up with ways to help us solve problems, you are effectively demonstrating that whatever your idea is, it is superfluous. It doesn't really matter. Okay, any questions? Any questions? Remember, yeah.
What forums are you interacting with these people, and what do you find is their understanding of like basic scientific method and facts?
Most of my debates have taken place on the JREF Internet Forum. How many of you are familiar with that? Anybody on the JREF forum? Raise your hand if you maybe don't use it much. I only got a couple. But how many people are familiar with James Randi, the amazing Randi? Oh, he has an internet forum. It's one of the... He's not on it very often. It's extremely rare to find James Randi himself on his own forum. But his organization runs this thing. It's one of the liveliest, most awesomest discussion groups on the internet, and that's where most of my action has taken place. Oh yeah, I wanted to mention that if you do go to the JREF forum, my username on the JREF forum is Wowbagger. But be aware, there are other Wowbaggers on there. On Ferengula, somebody else is named Wowbagger, and he writes good stuff too. I often accidentally get credit for it, which anyway. So what else? And so there were a few other things. There was a forum called Debate Nation that used to exist, where I had some of my earlier works on there, and I tried to go on some creationist things, like the Discovery Institute's one, like the one that what was their forum called? Whatever it was. They kind of, yeah. Yeah, I don't know. Whatever, like the Discovery Institute's thing was, I forget what it was, but I think they kicked me out. And okay, what else? Oh, and as far as basic understanding, the question was, what forums am I active in, and what's their basic understanding of science? It does vary a lot. A lot of them, when you ask them to define science, it's usually just superfluous with knowledge, like or like the ultimate knowledge about something. I have my own definition of science, if you'd like to hear it. I just got to remember what it is. Science is the discipline of acquiring new empirical knowledge. If what you're doing is not proactive or productive in any way for helping us acquire new knowledge, empirical in nature, then what you're doing cannot really be said to be science. Intelligent design, and that's what my approach demonstrates. They're not really doing science because they're not advancing science in any way. They're not helping us solve any particular things. The knowledge of sometimes they're very knowledgeable in things like biochemistry, and you just have to show them how computer algorithms are able to work out how many iterations of a process can yield arbitrary levels of complexity, and this can help us solve various numerous problems, including fields of engineering. I'll move on to another question.
You haven't brought up the idea of how does this cure disease? Because to me, that's the biggest argument against intelligent design. If we were intelligently designed, why are some people born, with problems? Why is there ALS and so forth?
I kind of learned early on, whenever you bring up these disease elements, the answer that usually comes back is, well, that's just microevolution. You're not proving that one species evolved into another, and so I got out of that habit. Now, actually, maybe it's a good idea to reintroduce that because it's because a lot of the foundation of evolution can be found in curing disease. I learned a little more recently that things like cancer, well, it was a couple years ago, but things like cancer, in effect, work in like a way that's eerily like a microcosm of evolution. Once various forms of cells fighting each other, not all cancer cells are able to survive their own onslaught when they're dominating each other for supremacy of reproducing and stuff like that. So a lot of the foundation of how evolution works can be found in nuggets like that. So maybe I'll work that back in. But I like the animal conservation examples better because you're dealing with cute animals and macroevolution usually applies.
You were saying earlier about one of the things we should bring up is how computer simulations over many iterations can develop an arbitrary level of complexity.
Yes.
I said that we should bring that up in debate. Can you point to a good resource for arguments for that, for a way to bring that up in such a, to argue that in such a way that it's easy to understand so that anyone can break that down?
Of course, whenever you bring that subject up, the typical comeback is, well, that's just a computer simulation, it doesn't count. So my focus has been on how computer simulations have been applied to field work. Because a lot of stuff you learn in simulations can then be applied to field work, and then there has to be a realistic simulation, otherwise it wouldn't match up with what we're finding there. Okay, but some good resources. There was a couple of specific algorithms, some specific things I know. Actually, you're probably better off talking to me later when I can look these things up. But off the top of my head, there was something called Tierra, which was able to simulate things like parasitism would just emerge spontaneously, even though it wasn't explicitly programmed into the thing. Nobody said this is going to act like a parasite. It just kind of happens there in the simulation, like whoa, you know, and. I'll probably be able to better answer that question when I'm able to look at the internet again. That's the problem with the internet. You sort of forget things in your own head.
How would intelligent designers respond to, for instance, the existence of the appendix?
I don't think I can recall a specific answer to that, actually. So that answers that. Actually, well, things like, I guess, the general concept of what's it called? Vestigial organs. You know, a lot of them like to say it's not really vestigial because it has a purpose. And it's like, well, that's not what vestigial means. You know, there are birds that clearly don't use their wings for flying anymore, and yet they remain on the birds. And they're probably useful for something of temperature regulation or balancing on top of various things. But you know, but they don't. Then they'll say, well, they were designed for that. So that's, you know, I guess that's all I can say on that subject. All right. Well, I guess that takes care of that.